Hello everyone. In this video, we are going to talk about the percentage composition and the determination of what empirical formula using the percentage composition, as well as determination of molecular mass or molecular formula in some cases when the common right ratio or some molecular mass is given, then we can calculate the molecular formula also. So we are going to talk about the two key point here, guys. Let me write down. So number one, the percentage composition. So percentage percentage composition and their uses. What is the usage of percentage composition and what is the importance of the percentage composition in chemistry, right? Because this is very important, percentage composition, because we'll be using where? In calculation of empirical formula as well as determination of the molecular formula of a compound. So this is a key point here. So second important topic will be there, guys. This one, the determination of empirical formula. Determination of so let's talk about determination of this one, empirical formula, right? Okay, guys. So what is the percentage composition, guys? See, you know everything is composed of something, right? So generally you talk about what? Your t-shirt, right? It's composed of what? You can say, sir, it's made of what? Some materials, right? The raw material like cotton and all, right? And then it will be what? Colors also, you're mixing up the colors and all, right? So same way we are talking about the composition of molecules, right? How the molecule is composed of, right? So there, of course, there will be some contribution of each element, right? You can say the molecule is composed of the atoms of the elements, right? So now we should know like how much contribution, right? Element, suppose A element contributed 10%, 20%, B element 30%, so 20, 30, 50, and the C element contributed 50%, right? So you know the percentage. But one more thing comes in mind, like percentage in terms of what? Right, guys? Percentage in terms of the mass, number. So this thing we are going to learn today, right? Because we know this is all like very basic, right? So we are going to talk about all these things in these videos, guys, right? So let's talk about the percentage composition, guys, right? So anyway, you know the percentage, guys. So not to discuss about the percentage. Now let's talk about the percentage composition, guys. Now the percentage composition, we are talking about percentage composition. We are talking in terms of the mass as well as the numbers also. So what is very important thing is the mass is the very famous one actually. So let's talk about the percentage composition in terms of the mass, guys, right? So number one, percentage composition by mass. So guys, here for a molecules, what is the component which constitute the molecules, right? It's the atom or atom of the element, right? So we can say the element, okay? So molecular formula, let's say like molecular formula is AX, AA, BB and CC, guys, right? So this is the molecular formula, guys, right? Now we are going generic phase. So this is the molecular formula, guys. Now if you are talking about percentage composition of A by mass in molecules, guys, will be what, guys? So you can say MA, mass of A divided by mass total into 100, right? So this we can say, right? This is the one. So what is the percentage composition of element A by mass in molecules, or in a substance we can say MA by total. Now remember here, if you're talking about M by M total, guys, this is the what? For if you take one molecule also the same, and if you take the M A total sample actually, that will be also the same, guys. So that you can do that one the homework, you guys. That I'll tell you is same actually. So now let's talk about the percentage composition of A by mass in a molecule. So what you do guys here, you can write down this one. So mass of A in a molecules divided by molecular mass. You can say the molecular mass actually M into 100. So this denotes what? Molecular mass. If you are talking about M total divided by total mass in that sample of A, or we can say atomic total mass of all atoms of element A in molecule divided by the molecular mass into 100, both are the same. These two are same thing guys. These two are the same thing guys, right? You can use the number of moles concept, the mole concept and all you can derive easily. I'm leaving this one. I'm hoping that you guys will be able to derive it. If not, then you can put in comment section. We'll do that derivation also. But as of now, we are leaving it. Okay. So this is the percentage composition definition by mass. Similarly, you can put for others also, right? You can put here by V, and then what would be there, guys? MV divided by molecular mass of the molecule into 100. Similarly, for the C, MC by M into 100. So guys, we know the percentage composition guys here, right? Now, main important thing is guys what? Empirical formula calculation guys. So you may have seen this table, right? In NCERT books as well as many places you will see this tables. But have you questions why that table, in that table you are dividing or something you are doing it? Or you are simply following the steps and you are able to calculate it? You are able to calculate it, you are happy. See guys, one who has fire for learning, right? One who is determined to learn guys, they will try to dig in, right? Why these tables? Why these steps? That they will be able to prove it guys, because they don't need to go for higher level mathematics and all to doing that, right? So let's go ahead. First I'll tell you how to calculate the empirical formula simple way, and then we'll prove it, like why we are doing so. Okay, so let's go ahead guys. So number one thing, what they given? Percentage composition of the elements will be given to you. So number one, percentage composition of element is given to you. So the percentage composition of elements are given. So this is the key point here guys. So the percentage composition of elements are given to you. Now they are asking you to calculate the empirical formula of the molecules, right? Okay guys. So let's denote it. Let's say like the elements are A, B and C are the elements. And their atomic masses are AA, AB and AC are atomic masses of element A, comma B, comma C guys, right? So this two data is given to you guys. Now what we're doing, we are making one tables. Pure NCERT way, right? Or 10+2 kind of guys, right? One who like believe in right just passing the 10+2. You will do this way actually, right? So let me tell you the element here. So this is the element, right? Now we'll put down here like the element. What the element guys? A, B, C. These three elements constituting or composing this particular molecules, right? So we are doing it A, B, C guys. We are writing here the percentage composition. So this table is what? Percentage composition guys. So we can say here the percent PA are the percentage PA, PB and PC are the percentage composition of element A comma B comma C respectively, guys, right? So we can say the PA, PB and PC, guys. Then what you are doing, guys? In the second, third columns you are making where you are dividing by atomic mass of each element, right? So this will be the P by A. P by A means what? Like percentage of composition divided by atomic mass, right? That's what you are doing it, right? So we can say PA by AA is atomic mass, PB by AB and PC by AC, guys. Okay. See, why we are doing this one? Nobody questions actually. Why we are doing so? Have you asked? Have you wondered why we are doing this one, right? Why we are dividing so? So you know that this is the way we are doing it, or we'll do also the same way, okay? So I'll tell you why here. This is a big question here. Why we are doing this division? The interesting thing here, you will be able to learn from that what the basic we learn, right? Mole concept, atomic mass unit, as well as we learn about empirical formula. From there you will be able to prove it, guys. I'll tell you right now. Okay, anyway. Now once you know this one, what you do? You are dividing. Divide by smallest. So suppose this we assume this is the smallest. So we can say, guys, this is the DA. DA means after division, DB and DC. Let's say like this is DC. So this is the smallest one. This is the smallest. Let's say it. So what you'll do? You'll do DA by DA by what, guys? DA by DB. Then you do, it will become 1, right? And this will become the DC by DC by DB, guys, right? So this one will become. Once you have this one, then you try to find out whether they are integer or not. If this guy is not integer, you multiply by suitable number to all, so that all become the integer. That's the key point here. Multiply by suitable numbers. So multiply by suitable numbers, right? Multiply by suitable numbers, guys, here. So let me write it clearly, guys. So multiply by suitable number to make it what, guys? Integer. Suitable number. So you multiply by something, right? Let's say that you multiply by something. So let's say that number is C. So you multiply by D by D into C, guys, and C, it becomes C, and then this we can say M later because the symbol is colliding actually. So anyway, we can use DC by DB, right? Now, guys, the step. See, now you can ask them why you are doing this one also. Why you are doing this one? So these 3 steps you should have the questions, right? But you need to know how it comes, right? You should have the proof also, right? Because this is not out of the scope of our syllabus actually. If it should have been, then we should have told you, like, okay, no need to go and you can skip it. But it's in the syllabus of. Okay, so now, guys, let's try to prove it, guys. So remember here, this we are doing it, and then we are dividing on this one. See, what is the main goal here? Why we are doing this actually, guys? Empirical formula is telling you what? It denotes simplest proportion of number of atoms of elements in a molecule, guys, right? This is the what we know. This is empirical formula, guys. So whole goal is what? To find the simplest proportion of the number of atoms in a molecules. This is the whole goal, right, for us, right? So this all is telling you that only, guys. So this will be related to some numbers. Actually, I'm telling you this will be related to some numbers. This will be related to make it some integer, means be simple proportion of the integer, guys. And this is what, guys? Yeah, this is related to simple integer, guys. These 2 steps is what? To make the simplest proportion of the integer, actually, right? So these 2 words. Now let me prove this one, guys. So everyone knows it, actually, this steps, right? I'm not putting you right the example here, but in future videos, or in the next video, we may put some questions here. But here goal is that first derive it, right? All the derivation, and then we'll go ahead for giving you the examples of it, right? If you have any doubt till now, you can ask it. Yes, you can now copy it and Then we'll continue for the next part of it, right? Proof of it. Okay, guys. So now, guys, for this one, percentage composition relevant to you, right? So now let's try to calculate the mass of individual. I think so. Individual element, and then we'll try to derive from the mass. We can derive the number of moles also, right? So this is the insight, right? How we can go, how we can proceed further. So remember here, the percentage composition is given to you in terms of mass. So once percentage composition is given to you, and the molecules molecular formula also we know it, then what we can do is you can derive the number of moles, right? Mass by molar mass by utility, guys. Or atomic mass, you will get the number of atoms or number of the molecules, right? So we'll try to derive it, right, in terms of the mole. So the mass is given, then we'll try to use it. Okay. So guys, here the percentage composition is given to you. So for element A, guys, right? Now goal is here, guys, find the number of atoms in our molecules, right? So well, you know the molecular mass, right? So we'll be able to calculate from percentage easily, right? The mass of, right, one atoms of the elements, right? So the mass of element A, mass of element A in molecules, in a molecule, guys. See, anyway, we are not calculating the actual mass in the samples. We are calculating mass of the elements in a molecules, because we know we are going to calculate the numbers and we are going to calculate the proportion also. So anyway, that if you go by the total mass also, it will get cancelled. So the number will get cancelled, guys, here. So we are taking the one molecules actually, guys, right? So how many atoms of A is there in a molecules? A atoms, right? So we can write down this one. A into A divided by, or we can write down simply the mass, guys. So we can write down this way, yeah, A into A divided by M. M is the molecular mass. So I am denoting for molecular mass into the 100. This will be the PA, guys. So sorry, this will be the PA. So we can convert, sorry. We can write down. I'm writing wrongly because we are calculating mass of the element of A in the molecules, right? So we can write down this one. Let's say like MA I'm writing. MA, what we can write down? The molecular mass into percentage composition is given to you, right? So we can write down the PA by 100, right? This one. Similarly, MB, we can write down M into PB by 100. Similarly, what we can say, MC, M into PC by 100. Okay, so the percentage composition of C by 100. Now you know the mass of 8 elements in a molecules. Now we can calculate the number. So we can say Na denotes what? The number of atoms of what? The element A. We can write down the MC, mass divided by what? The atomic mass. Sorry, MA divided by the atomic mass A, we can say, right? We can write down. So what we can write down here? This will be, guys, M into PA by 100 into A. Right? Similarly, you can write for others, right? Similarly, NB, you can write for others. So we can write down M into PB by 100 into AB. Similarly, NC we can write down M into PC by 100 into AC, guys, right? This you write down. This is the data number of. This is the number of atoms, you know, right? Now you know the number of atoms, guys. If you know the number of atoms, what we are going to do now? the simplest proportion of the number of atoms is our the goals, right? Is our the goals, guys, right? So let's try to calculate the simplest proportion, guys. So hope you have noted it down. If not, then pause and then note it. Then you can note it down. Okay, guys. So we are moving forward now. Okay, guys. So now you see, you will find it something interesting here now, guys. We are almost done, guys. This is the you had this is the thing you had derived it. Now see the from simple basic formula. The from basic formula of empirical formula. Now how we can from the definition, actually you can say that from definition we can derive this one, guys. So anyway, guys, now simplest proportion of number of atoms of elements. We can write down this will be like Na colon Nb colon Nc colon, right? This we can write down. So what will happen here, guys? So we write down M into Pa by 100, and then next we come Pa colon, and what we can write down, guys? M into Tb by 100 divided by Aab M into Pc by 100, right? So see what is the common, guys, that anyway in proportion it will go off, right? So this guy is common 100, this guy is common. So what you find? Pa by Pg colon Pb by Pg colon C by so Na colon Nb okay, guys, this is the one. So you see here what you are getting is number of atoms proportion Pa by Aa, the percentage composition divided by the atomic mass, percentage composition divided by atomic mass of B, percentage composition divided by atomic mass of the C, guys. So this is what you are doing in the tables. The third column, remember the third columns. What we are doing, guys? You are dividing the percentage composition by their atomic mass, percentage composition by atomic mass, and then percentage composition by atomic mass, guys. So I think something will be clicking in your mind right now, right? You see here, guys. So what you are going to derive it, guys? This one. So why we are doing so, guys? Now it's clear to you, right? It's to find the simplest proportion of the number of atoms. You are deriving. You are doing that one actually. So now you are able to derive it, guys. Now see this integer, this value may not be integer, but what is the simplest proportion? Proportion is always integer number, right? So 1 colon, comma 2 colon, comma 3 colon, right? Or something 1 colon 5 colon 6, right? So something like that, right? It should be integer, guys. So what you are doing? You are dividing by this one. The smallest you are finding, you are dividing it to make it what? The integer, right? So anyone, the smallest one, you are dividing it this one. Again, you are not finding the integer. What you are doing then? You can multiply by suitable number so that it get converted into the integer, guys. So hope you found it interesting, guys. We are able to prove it, guys. So that's what I was telling, right? We need to have desire to find through the mathematics, guys. We'll be able to derive it, guys. This is all basics. You will never find this and all. You will never find in the books, guys. And most of the time they'll assume it. You know it. You remember it. You mug it up and go and solve it. You'll be able to solve it, guys. That table is enough to solve the problems, but you'll not have that kind of the confidence, that kind of the inner, ability to think about that one actually, because you have never derived. Once you derive it, then you'll feel confident, guys. So we are stopping here, guys. We'll come up with the next interesting topic, guys, for you. Thank you very much. Please like, subscribe, and comment as much as possible, because we need your feedback to improve ourselves, actually, guys. Thank you very much.